Hi guys, welcome to this, my video on approximations, decimal places and significant figures. One of probably the most important videos for this general maths course. In fact, all the way through. Having just marked a load of year 12 sacks. Yes, some of the students still in that point did not know how to round to decimal places or significant figures. And one of my students sadly blames now the fact that he wasn't taught this before on the fact he did not get an A+. So make sure that you totally understand this video and practice, practice and practice. My name is Darren from Maths Guru. Thanks very much for watching. You know the drill by now if you've been watching my videos. If not, can you subscribe to my YouTube channel? It just lets me know that you're watching. And if you can tell your mates, your teachers, and subscribe on all those YouTube and sort of social media things, I would be deeply, deeply grateful. But enough of that rubbish. Let's get on with the good stuff. Now, I would normally go through the learning objectives, but come on, guys. You can read, and I'm pretty much going to go over, what is it, rounded numbers to scientific notation, significant figures, and decimal places. Ready? Let's get going. All right, now, although this is a new chapter, all right, so if you're following the Cambridge series of textbooks, and thank you, Cambridge, for allowing me to use your stuff, you will know that I'm about to launch into chapter 10 of that book, which is massive, and it's all the geometry and measurement and similarity stuff, all right? Really, really important for later on. But being able to round to decimal places and significant figures is so important. And VCAT in their exams absolutely knock you marks off if your answers aren't rounded appropriately. And by that, you haven't read the question and you haven't read two decimal places. Now, rounding to decimal places, I love decimal places because the rounding is in the title, decimal places. Right, so first things first, if we notice here, what do I have? I have a decimal point. Here is my decimal point. Now, each of the numbers after that decimal has a order. It's like a queue at the dinner hall, isn't it, you know? So the number 3 is at the front of the queue. The number 4 is one behind it. The number 5 after that. And so the number 3 in this situation is our first decimal place. Our 4 is our second decimal place. 5 is our third decimal place. Why? Because it is the third number after the decimal point. All right, awesome, yes? Now at the moment, as I say here, this number has 6 decimal places at the moment, but we don't want to always have all the numbers on our calculator. If I brought up my calculator for some of the calculations we do, the numbers go on to infinity and beyond, and we don't want to keep writing all of those down, do we? So we want to have some sort of rounding in place. Now, the most important rule for rounding is that if a number, and I'll come back to what I mean by if a number is 5 or more, the number before it rounds up by 1. If it's a 0 to 4, then the number stays the same. And again, I'll explain a little bit more about what that means in a moment. Everything I write on at the moment, you can download from, oh yes, mathsguru.com. Absolutely free to sign up. And there's lesson notes, there is videos, there's time codes, there are exam questions. There's so much more over there for you. Right, now, I want to round this number to 2 decimal places, for example. Now, if I want to round it to 2 decimal places, what it really means is I only need to be left with 2 numbers after my decimal point. All right, all the rest of the numbers are going to disappear. So what I tend to do here is I go, well, okay, let's do a dotted line after our second decimal place, and second number after the decimal place. And then what I do is I basically go, well, let's look at the number after the line. Is that a 5 or more? Well, absolutely, it is. And so the rules of this thing basically say, well, if this is a 5 or more, we make the number before it 1 bigger. Now, again, I tend to think of this as the number 34, and I'll explain a little bit later on why I think of that as the number 34, right? So how do I make 34 bigger? Well, I would make it 35. So that would become 0.35. And the 12 stays the same. So the numbers in front of the decimal place stay the same, and the 0.34 becomes 0.35. And again, all I've done is I've changed the 4 into a 5. Now, what happens with the rest of the numbers? And this is sort of key to this. All right, what happens to the 5, the 0, the 1, and the 6? Well, realistically speaking, they all become zeros. And what do we know about zeros at the end of a decimal number? They don't get ridden. And there we go. Or ridden or written. And there we go. I've rounded that to 2 decimal places. Let's rub it out and try a different one. What about if I was rounding it to 3 decimal places? Well, we want to do 3 numbers after the decimal point. Let's change a different color. All right, so there we go. There's my dotted line. And I am 147 years of age. And I still do this. I still do the dotted line. And what do I do now? I look at the number after. It's a 1. Do I change the number before that? Will this 5 change? No, because if the number I'm looking at is a 0 to 4, then this number here doesn't change. And so my number would stay as 12.345 to 3 decimal places. Now again, the best way to do this stuff is to practice and practice and practice. All right, now then we get to the rules for rounding to the nearest 10, 100, 1,000 example. So let's have a look at the number 3, 4, 8, 6, 7. Now a lot of this comes down to your place value from primary school. Yes, this one here is my units. This one here is my tens. This one here is my hundreds. And what do we have now? Thousands, and then tens of thousands, and so it goes on. So, for example, if I wanted to round 34,867 to the nearest 1,000, what I'm going to do is I'm going to do a dotted line after the number that stands for my 1,000. Oh, because there are 4,000, so 34,867. So I know that the number 4 is in my thousands. I draw my dotted line. And I say, right, now look at this number 8. Is the number 8 going to change the 4? It is, yes. Why? Because it's 5 or more. So the first thing I'm now going to do is that 4 is going to become a 5. What about the 3? Now again, sadly, lots of people get very confused here because they try and add 1 to everything. No, it's only the 4 that changes. All right, so then you got the 3. And again, lots of people go, oh, well, I'm done now. No, because what happens to all the rest of the numbers? So again, it's very similar to my decimal places, that once you've done that fudging, if you want to call it, once the 8 has changed the 4 into a 5, you replace all of those other numbers with zeros. And then you're going to turn around and say, well, I can get rid of them now, can't I? And I'm going to say no. Why can't we get rid of these numbers? Because they're not after a decimal place. Now, it seems like there's a lot to remember, doesn't it? But it really isn't once you've got practice and practice and practice. What if I wanted to round this, say, to the nearest 100? Well, again, sorry, if I wanted to round this to the nearest 100, I would find the numbers that's in my hundreds column and draw a dotted line after it. Will the 6 change the 8? Yes, it will. So the 8 becomes a 9. The 4 and the 3 stay the same. And the 6 and the 7, anything after that dotted line becomes zeros. Can I get rid of the zeros? No. Why can I not get rid of the zeros? Because I don't have a decimal point. And so, again, that would stay as it is. Again, you can download all of these notes. Now, the rules for rounding decimal numbers, as I've said over and over again, and this is for your summary book. If the one I'm trying to look at, if the number after the one I'm trying to keep is a 5 or more, then we add 1 to the number we're trying to keep. And again, I'll explain that in a moment. If the number after the one I'm trying to keep is 0 to 4, then we do not change the number we are trying to keep. Okay, so let's write this number out. 94738.2, 9, and 5. Round this to 2 decimal places. All right, well, there's my decimal place. So I'm now going to count 1, 2. So that's the number we're going to fact check. And I'm going to do a dotted line here. And then I'm going to look at the number after it, because this is the number we're trying to work out. Is that going to change? Is that 9 going to change? Well, that 5 tells me yes. I'm going to change the 9 into a 10? What happens there? Well, a lot of people go, oh, and make silly mistakes here. But I said to you, I always see this number here as 29, for example. Because when I add 1 onto 29, what do I get? I get 30. There's my decimal point. All the numbers before stay the same in this example, and there we go. What does the 5 become? It becomes a 0. Now let's look at whether I can get rid of all those zeros. Can I get rid of the zeros? I should, Coco. So in this situation, that 0 goes and that 0 goes. And I know there's a lot of confusion here because people go, well, I don't have 2 numbers after my decimal point. No, you don't. But in this situation, I could write the 3 0. It doesn't look mathematically correct because we know we can't have zeros at the end. So I'm going to leave it as 94,738.3. Again, practice, practice, practice. Let's use the number below to round to 1 decimal place, 2 decimal places, and 3 decimal places. All right, again, I'm just going to keep doing this so that you can see what happens. 1 decimal place. Where's my decimal point? It's here. Where is my first number after the decimal? It's there. So I'm going to draw a dotted line after the 4 and before the 9. Okay, now why do I do this? Just so I can work out, or does that 9 change the 4? Yes, it does. Why? because it's greater than 5. That 9 there is greater than 5, so the 4 changes. So that 4 becomes a 5. The 0 and the 1 stay the same. All the other numbers would become zeros, but because we've got the decimal point there, I don't need to worry about it. And there we go. And so what I would generally do in my working out is write in brackets 1 dp. Why? Because that tells the audience I've rounded to 1 decimal place. Now let's do it to 2 decimal places. Here we go. So 2 numbers after the decimal point puts my dotted line there. Again, does my 9 change that 9? Yes, it does. Now this 9 would make that 10. Well, let's not think of it as that. Let's think of this as 49. Well, what happens with 49 add 1? It becomes 50. And so 10.50. Now again, do I need that 0 at the end? Nope. So I'm going to get rid of it. And strangely, you'll notice that that now is the same when it's rounded to 2 decimal places. What? And let's do it to 3 decimal places. Goodness, could I have chosen a more complicated example? No, they're not complicated. Right, so here's my dotted line again after my 3 numbers after the decimal point. So does the 5 change the 9? Yes, it does. Shucks. What does it become? Well, again, I'm going to now look at this as 499. And what's one number bigger than 499? 500. Yep, so I'm going to write 10.500. Hold on a minute. Again, those numbers can go. And so 10.5 to 3 decimal places. Now, after that, it wouldn't. 4 decimal places, it would be 10.4995, and you can check that if you wish. But again, those dotted lines make life so much easier. Now, interestingly, we then get to what's called significant figures. And the way I remember this is it works in exactly the same way as decimal places, except we don't start counting at the decimal point. We start counting at the first non-zero number. And other than that, the rules stay pretty much the same. All right, so let's look at some examples for significant figures. It says here, write each number in scientific notation and then round to 2 significant figures. We'll come back to scientific notation a little bit later on. Let's just round these to 2 significant figures. And I'm going to write them a little bit over here again. So we've got 9764.809 and then 4. Now, it says round it to 2 significant figures, not decimal places. So in this situation, I'm not starting at the decimal point. I'm going to start at the first non-zero number. Well, if we look at our first number, it's 9. Okay, awesome. So that is now where I'm going to start counting. So that is my first significant figure. That is my second significant figure. So I'm now going to draw my dotted line after the second significant figure, and then the rules stay exactly the same. Does that 6 change the 7? I should Coco. So because that's 5 or more, the 7 now becomes an 8. So that 97 becomes 98. What do you do next? Replace all the rest of the numbers with 0, 0.0000. And what do we notice? I've got a 0.0000. Well, I don't need those. So they go, my decimal point goes, and there we go. So 9,764.8094 rounds to 9,800 to 2 significant figures. And again, notice I put there 2SF. Ooh, look at this number here. 0.000004716 with a floaty with an 8 on the end. Right, okay. So we're rounding to 2 significant figures. What does that tell me? That tells me that we are going to start counting at my first non-zero number. Well, that 0, that 0, that 0, that 0, and that 0. So this is my first significant figure. This one here is my second significant figure. So what I'm going to now do is I'm going to put a dotted line after my second significant figure. Now the worrying is there, that's a 1 there, but looking at the 1 after the line, will that change the 7? No, in this situation, whew, lucky. So that becomes 0.0000004.7. All the other numbers become zeros. And what do we know about zeros at the end of a decimal number? They can go. And there we go. So rounding that, I would write to 2 significant figures. So the rules are exactly the same. It's just where you start counting from. Round the following to 3 significant figures. Again, we can do this. All right, what have we got here? So the 5 is my first significant figure, then the 7, then the 8. So we started counting at the first non-zero number. 1, 2, 3. Right, let's do my dotted line after the 8. And what do we got to do for the 9? We've got to decide, does the 9 change the 8? Is it 5 or more? Yes, it is. So that becomes a 9, 0.7, and 5. All the rest of the numbers become zeros. But do I need them? No. Why? Because they are at the end of a decimal number. And so there we go. So that there is 57.9 to 3 significant figures. And the last one, where are we going to start counting? Do we start counting at the point, or do we start counting at the 4? Well, hopefully you're realizing it's the 4, because we can't start at a 0. So once we've got to that 4, we can start counting. So we got it to 1, 2, 3. There's my dotted line. What am I going to look at? The 6. Okay, does the 6 change the 1? Yup. So that 1 is going to become a 2. And 7, and 4, and 0, 0, 0.0. Notice how I actually do the number backwards. Nope, that was the wrong way on the camera. On the number backwards just to help me. The 6 and the 8 become zeros, but at the end of a decimal number. And so they go. And again, let's put that to 3 SF. And ka-ching, life is good. All right. Scientific notation is challenging, if I'm going to be brutally honest with you. It makes this video a little bit longer, but we don't like writing really, really big numbers. If we look at this example I put into my calculator here, I put in 1 and 20 zeros. And my calculator, I went, nah, I'm not going to write that. All right, because mathematicians are pretty lazy. All right, so what it's done is it's gone, right, well, can I find a quicker way of writing that? And it's written this strange notation here, 1E20. Well, basically, it's because your calculator can't basically write what that E really stands for. So I'm going to tell you now that 1E20 stands for 1 times 10 to the power of 20. We'll come back to that in a moment. So the E stands for the times 10, and the number after is a little floaty number on the times 10. Right? So if my calculator gave me 1E7, then that would be 1 times 10 to the 7. If it gave me 1.43, E6, then that would be 1.43 times 10 to the floaty 6. Now, basically, scientific notation is just a way of moving a decimal point, all right? It's moving it so that it falls between the first 2 digits, right? Now, in that situation, non-zero digits. The first number cannot be a 0, right? But I'll do a little bit more on that in a moment. So let's try and work out how this works. All right, so it's going to be pretty long, but we know that the number 10 is the same as 1 times 10. Happy with that? Awesome! And we know the number 100 is the same as 1 times 10 times 10. But we know that we can write that as 1 times 10 with a floaty 2, because if you remember, 10 times 10 can be written as 10 squared. So realistically, what I should be writing here is a little floaty 1. Now, we don't normally write the floaty 1, but it's going to make life a bit easier in a moment. So what about 1,000? 1,000 would be 1 times 10 times 10 times 10. But we know that that can be written as 1 times 10 to the floaty 3. Why? Because 10 times 10 times 10, using floaty number or index notation, when we've got 10 times 10 times 10, we can write it with 1 times 10 to the 3. And hold on a moment, you see what's happening? So 1 times 10 to the 20 is 1 times 10 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 times 10. You get the idea. 20 times. Whew. Or, in that situation, 1 and 20 zeros. Now, again, a lot of people try and get tricked by this because they go, so that 2 just means there's 2 zeros, and that 3 just means there are 3 zeros. What it's actually meaning is that I've moved my decimal point 3 places to the left, right? And again, I'll come back to that in a moment. So if we had 10,000, I can write that as 1 times 10 to the 4. All right, and again, we keep going on. So that's what this means. A calculator is writing really long things into small. Now again, what I'm going to say here is if I look at the number 10,000, where is the decimal point at the moment? It is here. And what we need to be able to do with scientific notation is move that so that the decimal point is between the first 2 numbers, that the first one isn't 0. And again, I'll come back to that later. So what I'm saying is we can jump that 1, 2, 3, 4 places. So we want the decimal point to go there. So we want it to be 1.0000. We're going to write times 10, because the reason we're writing this times 10 is we've got to tell people that we've got to move the decimal point back, or we've got to tell it how many places it's moved. And because it's moved 4 places, we write times 10 to the 4. Now, again, because we've got a decimal number here with all my zeros, after my decimal point, I don't need it, and so I can effectively write this as 1 times 10 to the 4. Whoa! So scientific notation is basically that. But what about smaller numbers? Well, if we have smaller numbers, so for example 0.0001, we have to move our decimal point so that it is after the first non-zero number. That's probably a better way to do it. We've got to move the decimal point. Now, as we can see here, where is my decimal point? It's just after the 0. So I can't have it there for scientific notation. So what about if I jumped in one place there? Well, no, that's going to put it after another 0, so that's no good. What about if I move it there? Nope, no good. What about if I move it there? Nope, no good. What about if I move it here? Ah, that works. So my decimal number now can become 1 point. Well, what's after the point? Well, actually a load of zeros, so actually I don't need to write that. I can write times 10. Now, we just have to put the number of places my decimal point moved, and we can count the bumps. 1, 2, 3, 4. But hold on a moment, I told you that that was the same as 1 times 10 times 10 times 10 times 10. And if I put that into my calculator, I am definitely not going to get 0.0001. 0.0001. Yeah, I got that right. So what we do is when we move the decimal point to the right, we actually have to make this a minus number so that we can say to the people, hey, this is a really small number. And what we find is that really big numbers, numbers that are bigger than 1, will have a positive floating number. Numbers that are smaller than 1 will have a negative floating number. But again, when I taught this in the UK, all I used to think of this was bouncing decimals. How many places am I bouncing the decimal? Put the number on top of the times 10 and just make sure you got the plus and the minus in the right place. All right, converting from scientific notation, well, again, now we need to be able to undo it. So if I had the number 1.34 times 10 to the floaty 3, I want to now turn that back into a number. And what we got to remember is that that is the same as 1.34 times 10 times 10 times 10, which is 1,000. Now again, if we go back to our junior school maths, when you multiply by 10 or 100 or 1,000, which way do you move your decimal point? Well, you're going to move it that way. So I'm now going to move my decimal point 3 places. So I've got my 1.34. Let's bounce it. 1, 2, 3. Hold on a moment. I've just jumped over. Well, there's nothing there. Oh, yeah, there is. There's a big fat nothing there. So my decimal point has changed from between the 1 and the 3 to the end there. Now, obviously, is there anything after that decimal point? Well, yes, there's a load of zeros, but we know that when the decimal point's at the end of the number, we don't need to write it. And so I have now converted 1.34 times 10 to the floaty 3 into 1340. Let's do another one. I like this. So 2.763 times 10 to the floaty 2. Right, so that's going to be the same as 2.763 times 10 to the floaty 2 is 100. All right, so how many places am I moving my decimal point that way? 2. Why do we do it 2? Because that floaty 2 tells me to. And so again, I'm going to jump it 1, 2 places. That means it's going to end up between the 6 and the 3. So I've got 276.3. Is that my final answer? Absolutely. Can I get rid of the 3 on the end? No, because it's not a 0. And so ultimately, there we go. That is my positive powers. Now again, we have negative powers. So if I had 1.27 times 10 in this situation to the minus 2. Now the minus 2 basically means that we've moved it to the right, getting it into that number. So I'd have to move it to the left. He says trying to get this the right way, to the left to undo it. How many places am I going to move it? I'm going to move it 2. So there was my 1.27. I'm going to move it 2 places to the left. 1, 2. So that's where my decimal point is going to end up. hold on a moment, there's nothing here. Yes, there is. There is a big fat nothing there. Now again, lots of people then turn around and go, oh, I'll just leave my answer like that. No. Anyone out there who tells you to just leave a floating decimal point out there is wrong. Very, very wrong. And so we don't leave a floating decimal. We would put the 0 there. And so 0.0127 is that number. Should we do another one? Yes, please. All right, I know this is a long video, but it's really, really important. So what have we got here? 1.047 times 10 to the minus, let's say, 3. All right. So the minus number tells me it was a really small number. It's going to be a 0.00 number. So I've got to move 3 jumps to the, what's that hand? Left? Yep, 3 jumps to the left. So again, I always write my number out. 1.047, and I'm going to jump it 1, 2, 3 places. That's where my decimal is going to be, so it's no longer there. I've jumped over 2 gaps, so it must be zeros, and I put a 0 in the front of there. And so writing that out gives me 0.001047. Ka-ching. And again, if that seems complicated, I get it, guys. I really, really do. It's probably one of the most pointless parts of this course. He says, upsetting just about everyone out there, but it is something that you need to be able to master. Now, believe it or not, that there is the end of this lesson. Oh, thank you very much for watching. Hopefully you've enjoyed it. It's dealt with decimal numbers, scientific notation, and significant figures, which, you know, decimal places and scientific figures are very, very similar. Do me a favor, if you can subscribe to my YouTube channel, Maths Guru, that would be awesome. If you could do me the great favor of going to mathsguru.com and signing up, even better. And tell your mates and your teachers if you have found this useful. I'm going to go off and record the rest of chapter 10. So hopefully I'll see you in one of those videos. If not, please take care and stay safe. Bye-bye.